We are now talking about a technology called Silrich. What we are discussing is how the biomass, which can be decomposed to make organic fertilizer. The biomass after decomposition, when it becomes organic fertilizer, when they apply to soil, it increases soil organic matter. Soil organic matter composition when increases, we have a mineralization process by bacteria and we get soil organic carbon. Soil organic carbon is the heart and soul of soil. Soil is becoming bankrupt day by day by overuse and abuse of chemical fertilizers, abuse of pesticides and abuse of herbicides. With labor not being available even in countries like India, use of herbicide is becoming day by day more important. It means to say, farmer is forced to apply more herbicides, thereby killing more soil bacteria and making soil more bankrupt. This serious decline in the soil beneficial bacteria of not only nitrogen fixing bacteria, phosphobacteria, potash bacteria, mobilizing bacteria, silica solubilizing bacteria, trichoderma. This is one reduction. Parallelly, we have n number of fungi, actinomycetes, bacteria, which are responsible for decomposition of biomass. This decomposition of biomass needs the help of bacteria, needs the help of fungi. With the depletion happening for last many decades now, soil organic matter is not going up, it is declining. Soil organic carbon is declining, thereby we are not able to have adequate number of bacteria, adequate varieties of bacteria. Biodiversity is lost and the quality is lost. Number is lost. So what do? We are again depending more and more and more on chemical origin fertilizers, mining origin fertilizers, fossil fuel origin fertilizers. Compost is such a fantastic organic fertilizer with rich in NPK in available form. We have forgotten to use it. Why? Oh no, the dung is available but it doesn't digest. Considering all the limitation, without any organic matter, any biomass, maybe leaves, grass, root, debris, anything which is fallen in the ground, including weeds, can be decomposed by excellent microbial organisms. There are good number of fungi, good number of bacteria which decompose the biomass. The decomposed biomass becomes organic fertilizer, and that organic fertilizer enriches soil organic matter and soil organic carbon. Therefore, we made a judicious blend of decomposing cultures. What do they decompose? Biomass has cellulose, simple dung. Dung kind of a biomass has more cellulose. We have fiber, cotton stalk, more java, the fibrous material. It means some biomass are rich in lignin. Some biomass, like in Malaysia, Indonesia, you have empty fruit bunch of oil palm. They call EFB, empty fruit bunch. Monumental volumes are stored. It catches fire. It pollutes the whole area. That contains large amount of cellulose, lignin, protein and lipids. Imagine a tough organic matter. You see in Indian capital of New Delhi, every winter we have problem. Farmers from a state called Punjab, Haryana, to neighboring states of national capital, they burn the crop residue. millions of tons are burnt. Tragedy is that. And that smoke travels towards Delhi. In the winter, there's already a fog. The smoke comes and the smog forms, and the pollution level goes to enormously high level. The kind of pollution problem created by this kind of burning of crop residue is monumental in some states. Therefore, we looked at how we can address this problem. So, a judicious combination of cellulose decomposing bacteria, lignin decomposing bacteria, some cases, the lipid decomposition substances like enzymes, protein decomposition enzymes. So all kinds of judicious decomposing agents we studied and came out with 3 kind of formulations of product. Technology is called Silrich. Silrich essentially is decomposing technology. Convert waste to wealth. Convert debris into organic fertilizer. Convert biomass into compost. The first product is called Silrich A. Silrich A is decomposing culture or compost culture we call it for simple biomass like cow dung. With plenty in the country. Predominantly cellulose decomposing microbes and lignin decomposing microbes. We have in this Cellulomonas uda, Cellulomonas gelida, Trichoderma ricci, the Aspergillus avamori, these kind of cellulose and lignin decomposing bacteria. 1 kilogram per cubic meter of the biomass is good enough. A cubic meter may be based on the moisture level, maybe 700 kg, 650 kilograms, 800 kilograms of material, biomass material. Layer by layer we can put the biomass, mix Silrich A 1 liter into say 100 liters of water, simply splash that water, mix water on the layer. Again increase by 10 centimeter, 10 centimeter, 10 centimeters. Every layer you splash. We can make a windrow of 1 meter width, 10 centimeters height. Any length is okay. And spray and then I incorporate Silrich A. Another 10 centimeters, another application. We can go up to 1 meter height. It means 1 meter width, 1 meter height, length can be any longer. Simple shade is enough. The microbes cause a lot of fermentation. Heat gets developed. So the biomass can become dry. Every few days once, some water has to be sprinkled to keep enough moisture for the microbes to work and decompose the biomass. Normally in about 30-35 days time, this cow dung kind of biomass gets decomposed, and you can put your hand inside the heap, and if it is still not very hot, it means the decomposition has happened, composting process happened. You can take out that, you can sieve it in a normal jolly kind of sieves. Undigested material can put back to compost bed for next cycle of Silrich A treatment and take it up this for application. This kind of product, Silrich A applied compost, anywhere from people can apply 1 ton per acre to 3 tons per acre per season application. And once it is composted, you can keep any number of years, there is no problem. This is regarding Silrich A. As I explained, we have other kinds of hard to digest biomass. Like I explained to you about empty fruit bunch. Coir pith, cocoa peat we call it. Very, very tough, very high in lignin, very high in sometimes proteins like this empty fruit bunch. Lipids. We use for that certain other microbes apart from Silrich A microbes which can decompose lignin and protein and also lipids. So we have other set of microbial organisms blended with Silrich organisms that we call Silrich P1 as a product. So Silrich P1 is a product for high lignin, high protein, high lipid content biomass. The dose is same, 1 kilogram per cubic meter of product, and the layer by layer application and making a windrow of 1 meter width, 1 meter height with 10 layers of treatment. The same system is recommended for Silrich P1 also. Then we have another interesting conditions. Some countries where the temperature is very low, it goes to 5, 6, 3, 2 minus, and microbial organisms will not work for decomposition at such low temperature. They go to sleep. But we need to decompose the biomass. Then we take the help of enzymes. So we make a technology called Silrich EN. EN stands for enzyme. We take enzymes like cellulase for decomposing cellulose, hemicellulase, lignase, like this, protein for protease. Like this blend of enzymes are used to make Silrich EN. This is not temperature dependent. Even at low temperature, Silrich EN can start fermentation process, digestion process, and break the lignin, cellulose, and lipids and protein. The dose there also is just 1 kilogram per cubic meter. Thus, Silrich A is for normal biomass. Silrich P1 is for high lignin biomass and high protein or lipid biomass. Silrich EN is high lignin, high protein, or maybe high lipids, but low temperature conditions in many parts of the world. So these are the 3 Silrich we use for decomposing. And after decomposing, we get the organic fertilizer, compost. How do we enrich it? We have Silrich B formulation. Silrich B is a blend of nitrogen fixing bacteria, phosphorus solubilizing bacteria, potash mobilizing bacteria, zinc, iron mobilizing bacteria, silicate mobilizing bacteria, mycorrhiza. All this blend is called Silrich B. We recommend Silrich B to be applied just before the compost applied to the field. Mix 1 kilogram of Silrich B per ton of compost made by a Silrich process. So the compost to apply is not just a compost, it is enriched compost, enriched with a lot of microorganisms. The one to apply with this compost, they start growing very well. All this Silrich A, Silrich P1, Silrich EN are for decomposing, Silrich B is for enhancement culture. Thus the Silrich bacteria microbial process fermentation is simpler to make, and all the biomass can be converted in the field condition itself. With no special equipment here, farmers can make their own compost. This is the background of Silrich technology. Thank you very much.